It's really great honor to talk to entire Aerospike customers as well as technology leaders about very interesting work we are doing actually at Adobe related to real-time streaming segmentation using Aerospike and Azure. My name is Sandeep Nawate. I run the engineering for RT CDP and many other products at Adobe. This journey with Aerospike has been ongoing for the last 6 plus 7 years. We've been working with Aerospike very closely over this time, and I want to just get through explaining how things are. Here's an agenda for my talk today. I'm going to briefly introduce the Adobe Experience Platform and the RT CDP. This acronym will be coming up very often. It means Real-Time Customer Data Platform. Specific problem we're going to be discussing is the query processing within RT CDP, how we achieved essentially efficient solution for extreme scales, and I'll explain what those are, and some of the conclusions and observations we have made as well as the future direction. So to start with Adobe Experience Platform, just want to kind of explain essentially Adobe's larger picture here. Adobe is well known for the products which are Acrobat and Photoshop and many others, which are all the creativity tools. I'm talking about a different aspect of Adobe, which is called the Adobe DX side or the experience side of the business. This is essentially powered by what we call the Adobe Experience Platform. Adobe Experience Cloud, the centerpiece is the Adobe Experience Platform, which has been built completely organically within Adobe within last 5 or 6 years. Most of the Adobe's well-known solutions, which have been acquisitions in past, all work on top of this platform, and some of those include most recent acquisition like Workfront, Adobe Experience Manager, Adobe Target, Adobe Campaign, the Marketo, etc., etc. Along with that, there are certain new applications that have come up, which is essentially based on the profile and identity, includes real-time customer data platform or RT CDP, which is going to be the focus of this discussion today. Going to the actually next level of details, the Adobe Experience Platform itself, if you were to start looking at it, this is completely organically built within. This component actually, the Adobe Experience Platform, supports natively built applications such as Real-Time CDP, Customer Data Platform, Journey Optimizer, Customer Journey Analytics, and many more to come. So this is where the connected customer experience gets delivered, and this is the platform that Adobe has been building. This platform has been in production now for the last 3+ years, and here are some of the interesting numbers to kind of look at. Nearly 1,200 brands actually across the globe are using this. There are 450 plus partner integrations that already exist. There are 31 billion profiles. There are 30 trillion or higher queries getting running every single day. This last one, actually statistic, is an important aspect, and the query processing is where our focus is going to be today. Just to kind of look at the business from the perspective of where the customer real-time CDP customer base is, pretty much who's who in the industry at the enterprise scale is working with Adobe today. You're seeing the names here such as Home Depot, Coca-Cola, Workday, etc. All these are well-known names. They are all today using real-time customer data platform. And we will be now getting into just brief description of what an RT CDP is and what are the problems of query processing that we are talking about. Just as a side note here, the imagery that you're seeing here actually gets generated by Firefly. This is the generative AI part that Adobe just recently launched a tool. If you get an opportunity to pick up a login there, your slideware, you can actually just build saying, just type what you need to get, you'll get a new slideware coming out of it. And I'm just having fun building imagery for my slides. The problem that we're going to be talking about is the RT CDP query processing, also known as segmentation. Before getting into the segmentation problem itself, let's start looking at the description of RT CDP itself. Here is a RT CDP schematics that I'm actually looking at. By the name, this is essentially customer data platform. Right at the center, what you're looking here is the customer data. Customer data is at a person level. In a B2C business, there will be person level profile that's getting built. At B2B level, it will be accounts and businesses, opportunities, leads. These kind of things essentially become the entities for which you're building essentially a unified store. That unified store is the key piece of what RT CDP is. On the left-hand side, you have data sources. Data sources are large number of data sources that actually bring in the data. The data arrives as behavioral data, arrives as enterprise data sets such as CRM data sets, federated data sources, partner data. All this data is ingested either in a batch manner or is ingested in a streaming manner. The data gets ingested into the unified profile store. Each location that actually provides the data or each channel that provides the data has a different identity. This causes essentially distinct identities that need to come together. As a result, what you're looking at is identity resolution and identity stitching is required. On top of that, the piece that actually becomes very critical is the segmentation or the query processing. So all this data along with identity runs through query processing, and we'll look at the query processing examples itself, what query processing actually involves. And these queries generate what we call audiences. Simplest way to think about audiences is that it's a list of users, like list of email addresses, maybe along with first name, last name, or along with the last product the person has browsed, because I'm building an email. That is a communication that is going to the individual person. On the right-hand side, what you have is a large number of destinations. Destinations essentially are the places where these audiences are actually being dispatched to. Typical destinations for the advertising side would be DMPs and DSPs. ESPs, which is email service providers, essentially where you're doing outbound email channels. You're doing personalization, which is typically the web personalization, in-app personalization. These are the personalization channels. Customer support, help desk, there are operational kind of situations where these audiences are being sent out. This is the overall picture of what RT CDP is responsible for. Segmentation is a core piece at the top of it. This is the problem set that we're looking at, the problems that exist here, and how we actually solve it. Before getting into the problems itself, let's understand what the segmentation queries actually look like. I have given 3 examples here. Segment queries come in multitude of forms, and here is a simple English explanations. I didn't want to kind of just explain this in terms of the SQL or any other language, such as what we internally call PQL, profile query language. First example, this is essentially men who visited a website in last 7 days and later purchased a product in last 48 hours from a stores in Western states. If you try to analyze this query, you're looking at essentially data which is profile data, such as attributes about the profile of a man living in a Western state. So these are the attributes that are important. Visited a website in 7 days is a behavioral data set that you have to kind of look at. So now we have 2 data sets. One is profile attribute data as well as behavioral data. And a web visit is essentially happening in 7 days is one other criteria. Last one is that purchased a product in last 48 hours from a store. So here the store needs to be in a Western state and the purchase event, again, a behavioral event in a different data set. And there is also a dependency where the prior event, which is visit to the website, is prior to the purchase. So it's a time series actually sequencing that needs to be done, or a time series join that needs to happen. That's a characteristic of the first example. So you can see that there are 3 different data sets involved, as well as a time series join that is actually happening. Second example, it would be a typical of, let's say, an airline. Gold Star members who have been upgraded to Platinum in last 30 days have visited websites in last 1 week multiple times and explored family travel packages. Now, again, here, if you start looking at it is system that is actually providing the data, ERP system that's providing data about the membership upgrades. Membership upgrades may be coming in real time also, which is streaming manner. Visit on the websites are actually about website visit data, which is behavioral data. Multiple times in a week requires actually kind of just counting across the time, as well as trying to understand that the visits were specific about family travel packages. So you need to know that the packages that were explored were the family travel packages may require a dimensional join. So that's the characteristic of the second one. The third one comes from a completely different domain. Now we're talking about the data is about accounts and the relationship of people with the accounts. So all accounts with a yearly opportunity greater than $1 million, find all the director level people associated with that accounts who have downloaded the white paper. A completely different characteristics. Again, all 3 examples, you can see that multiple data sets get involved and multiple joins are required. So this is a typical style of what a segment queries actually mean, and segmentation is happening. Let's understand the workloads that the segmentation actually creates. This slide has a lot of dense information. I'm going to just briefly explain what this slide is about. There are 3 major workloads that we actually look at based on how the segmentation actually needs to be done and query processing needs to be done. A batch workload, interactive or ad hoc workload, and real-time workload. In the real-time, in the batch workload, you're looking at essentially processing up to 10,000 queries simultaneously on a recurring or an ad hoc schedule. So typical, the trigger actually is a schedule. Expected latency is low, hours. Interactive or ad hoc query is typically when somebody sitting at a console typing a query gets a result. The number of simultaneous queries that run is simply number of people simultaneously at the console who are running the queries. We expect that 10 subqueries will be running no more than that. Latency expectation, however, seconds to minutes. Now let's look at the last one, which is the more important of this particular talk, which is real-time actually segmentation. The trigger here is an incoming event, such as a person visits a website, immediately cause a qualification. That's an experience event. A profile update event. If you looked at one of the queries, person getting upgraded from gold membership to platinum is a profile update event that arrived. These are the triggers that cause the segmentation to start. Number of queries to be evaluated, again in 10,000 kind of range. Expected latency is very different, milliseconds. So now we start looking at the workload characteristics are very different. Latency expectations are different. In general, when we start looking at these workloads, there's one particular theme that arises. And we actually look at it in a form like a cap theorem. Just want to explain briefly what this actually kind of means. Size of data. So typically profile data is in tens of terabytes going to several hundreds of terabytes of data. This is the size of the data. Freshness of the data is that the profile data is continuously getting updated. How fresh data you can get, how fresh identities you can actually load, that is the freshness constraint. Latency is of the query, is how fast you can run the query. And one important assertion is that you cannot build one query engine that can simultaneously optimize for all three. So size, freshness, and latency cannot simultaneously be optimal. So you have to build essentially three distinct essentially engines, each for one of the two groupings that you have to optimize for. That's the right bottom side that we're talking about, which is high scale segmentation is same as batch segmentation, optimized for size and freshness. Latency is not optimal. Real time is optimized for actually freshness and latency, but the size is small because it's a one profile at a time segmentation. Versus the last one, which is the interactive, which is large size of data, low latency, but the freshness is lower because you're doing pre-computation of all the indexes and optimal structures to make sure your queries can run fast on large data sets. So that's kind of how the segmentation workloads look like. Our focus here is going to be that real-time portion of how the queries actually get run. Now let's look at the queries and what is the real-time segmentation SLTs actually are there. So overall anatomy of the real-time segmentation. An event arrives as either a batch segmentation event or a streaming segmentation event. Incoming event essentially triggers the evaluation of the query. Up to 20 data sets are loaded for a single profile. The important aspect here to think about is that a profile is not one single thing. It's a set of data coming from various different systems, ERP system, behavioral data, back office systems, etc., that all getting combined together. Up to 20 data sets come together for a single profile. Think about saying then there are identities. Each data set may have different identities. We see up to 5 to 50 identities for a single identity graph for a person. This particular complexity, 20 data sets plus identities, is a lookup complexity and a join complexity. All this data gets joined together to create one unified profile. And now against that profile, you're evaluating multiple queries. This processing is for single query event. After evaluating query, you have to write back the results into the profile. So this is the overall process for one single event. Now you start looking at saying that for a one single customer sandbox, what happens? A typical number of event arrival is we are expecting for peak load getting to 100,000 events. Typical load tends to be 5-10,000 plus. Number of segments evaluation, or number of queries to be evaluated in 10,000 is typical number that we are looking at to solve for. Individual profile across all the data sets for single person gets into megabyte in size. Evaluation latencies. I talked about the system overall, which is edge evaluation latency is 100 milliseconds and hub of in seconds. I do want to just quickly explain this edge versus hub. The overall architecture of the AEP, Adobe Experience Platform, or RT CDP, is built on a hub and spoke model. Our hubs are located actually in Azure. The spokes are located in AWS. In the hub infrastructure today is where we are looking at streaming segmentation actually happens, or real-time segmentation. Hub also, the same behavior actually happens. They expect SLTs, actually expectations are slightly different between two places. The overall system scale when you're talking about, which is from a single sandbox, now go to the next level, is 2,000 plus sandboxes across all customers. So you see the complexity for one event, for one sandbox, and then for the system level scale. This is the overall complexity. The first version of this system that was actually deployed for doing this real-time segmentation was based on actually doing a direct access lookup against a store, which is a core real-time customer data platform store, what is based on Cosmos DB, looking up the profile, then evaluating all the queries and writing back the results. The observation in that one was that scaling up this particular system for the required SLTs that are given here was extremely hard. We could not actually get the scales, and I want to show before and after what actually happened. So now that we have actually set the problem stage as to what problem we are solving, I want to kind of also start talking about now how we got to actually providing a solution for this particular problem. Again, image coming for Firefly. This is a solution we are looking at. And this is essentially efficient solution for that extreme scales we are looking at for query processing. So the three different parts of the solution that we were looking at were essentially trying to figure out how the query processing can be actually done differently, using Aerospike as an underneath store for actually doing the access APIs and lookups that are actually needed, and using the strengths of Aerospike to also change the query processing dynamics, how we actually going to do. And I'm going to explain some of these concepts better. So query decomposition here was that original queries, as we saw, had multiple different components to it and some join constraints. The query decomposition goes after actually kind of looking at saying that different data sets and predicates being isolated from each other and doing delayed joins as and when appropriate, and essentially taking the component results such that the join complexity, you're not looking at the entire data set at the time of doing joins. So this was one important thing. And this is kind of an important milestone to kind of just say the query decomposition is happening. And simplest way to think about saying profile attributes versus events are being decomposed, events further getting decomposed by different data sets. Incremental query processing. This is the other concept we had to get to, that a typical query processing in streaming, you can actually maintain the temp tables and maintain all the data that is actually going by. And against the temp tables, you can keep on evaluating, which is temp table is your typical window of processing, and evaluate queries against it. Now, this kind of processing cycle does not scale for the scales we are looking at and the number of queries we are looking at. Because you have to understand that it is 10,000 queries for a single sandbox and you have 2,000 sandboxes. You cannot keep on running the number of actually kind of windows that you're creating query-specific basis. So you have to kind of start thinking about consolidation of this. The important thing that we actually kind of built was the incremental state-based query process. So after decomposing each actually individual data set, you can maintain the query processing state. State is a highly compressed information that actually kind of figures out whether query can be materialized. And then those results essentially go back and forth between Aerospike storage, and a very fast lookup actually can use it. Last one is essentially Aerospike kind of store, which is the data, which is incremental state management goes into Aerospike. The lookups, which are decomposed lookups, are actually coming from Aerospike, as well as storage of the results, which is once you compute the segments, goes back to the Aerospike. If you start thinking about the new process by which this composition actually kind of, the overall process actually starts working, is that you're looking at individual events getting loaded, individual events actually coming either from a pipeline or directly coming on the wire, which is profile update event or a behavioral event. You are essentially starting to process that particular event. The first step is typically just processing the event by itself without loading any data, seeing whether anything is likely to get impacted, if any predicate is likely to materialize. At this point, you're loading the query state for that particular data set. Evaluate further and say query state doesn't materialize into any predicate satisfaction that actually happens. Once that happens, carry forward that result, load rest of the profile data. Again, the profile data is specific to what is needed based on decomposition. Get that much data in, do all the joins, finish that piece of work. This is the third leg of work. Now the fourth one is, if that materializes into one or more segments getting materialized, then the segment and the payload, which is essentially the projection part of the query processing, gets written back into Aerospike. So these are the 4 steps that actually everything kind of goes through. The important actually change here was that actually doing query decomposition along with using Aerospike for handling 3 different aspects of read-write kind of cycle. We started looking at an architecture looking something like this. Now in this architecture, there's one other thing I do want to kind of call out was that as we are looking at our overall infrastructure, there are several thousand sandboxes that we're looking at managing on behalf of customers. Several of the sandboxes are for dev and staging environments, and of course, there are production environments where these things are run. We decided to take an approach of doing a multimodal tenancy instead of going a pure single tenancy. Using namespace isolation within Aerospike, we can actually handle essentially the governance as well as the customer managed keys and several other things. So all the isolation requirements, the encryption requirements are fully manageable using namespaces. So there was a possible way to start thinking that can we combine the low volume clusters all into a single low volume sandboxes into a single cluster, such as dev staging environments, a multi-tenanted cluster, and maybe build multiple of these. And then for the production large clusters, essentially do a single tenanted. And this essentially reduced the total number of managed clusters from Aerospike that we're looking at to a number in several hundreds from several thousands. So it's a reduction of at least 5 to 10x from the numbers that we're looking at, saying we can reduce the number of clusters. And you can understand that managing that many clusters at once, it becomes challenging. And of course, as business grows, more and more clusters are going to be needed. The AEP provisioning on the left-hand side is where the actual incoming calls come for a new customer getting onboarded and their expectations of the clusters. Cluster Manager actually goes and provisions clusters with Aerospike's managed service on top of Azure. These managed clusters are actually managed for a certain level of service that is provided. So amount of data and amount of throughput we're going to provide, we manage at that level. The actual real-time application, the one that actually handles real-time segmentation, has to do segmentation, lookup, ingestion, looks up the profile data, profile state information, and writes back the evaluation results. And that essentially cycle just continues for the typical throughputs. We are saying about 500K per second is a throughput that we see. The sizes of data, because we actually did this problem decomposition as well as compressed state management, the data size actually we could actually reduce. Now, remember that this data is a copy of the data that comes from the main store. So this is the data, actually operations that we have actually managed, and the deployments essentially are ongoing. We're seeing actually very good results here. So I want to call out some of the actual conclusions and the results that we are seeing. So most important thing was that the scale here, when we start looking at, improved almost 100x. We were about a 1500 requests per second. Now we are at 150K requests per second for a single sandbox. That 100x scale improvement happened with the latency improvement, which was at 300 milliseconds with P95. Understand that the 300 millisecond was 20 different actually data sets getting loaded, joined, and running actually entire query processing on it. That is improved to now 20 milliseconds at P99. That's at 15x actually latency. Other thing that has happened is that the I/O costs now are more predictable for us, because with Cosmos DB, it's a continuous variant that actually comes into play. Compute costs are actually now tied to more the requests per second that are actually running through the system. So that has also become kind of very important for us. The operating overheads, when you start looking at it, managed services from Aerospike has reduced the DevOps actually burden. So we are seeing essentially an equivalent managed service becoming available now in cloud on Azure, and of course AWS is already available. The multimodal tenancy has reduced the noisy neighbor problems, because we can actually have single tenants separated, which are two production clusters, dev staging is somewhere else, and still governance is fully intact. So that was very important for us. I/O characteristics actually are relatively stable. So the backups in processing, right? Whenever you're kind of processing streaming way, you want to kind of make sure that your pipeline is not getting backed up. We are seeing essentially the system is relatively stable in terms of how the operations are happening. All these results are very, very encouraging. The actual TCO numbers, we are still actually in the computational phase. We'll actually compute that. Maybe at some next opportunity, I will be actually presenting those numbers. The future workloads we're actually looking at, where we are actually moving to that, as this experiment is actually becoming successful, we're finding that a managed service for a data store or a database within cloud, now AWS and Azure, is becoming very attractive. And we're looking at new workloads migrating to Aerospike. We have already done that work in AWS. I mentioned that our original actually deployments for all edge locations was Aerospike. In the hub now, we are actually using Aerospike for the real-time streaming segmentation, providing actually really big benefits. Also, this particular kind of a workload migration with Aerospike is opening up the public-private cloud expansions, because we are right now kind of just tied with based on what services we have available from where. We are looking at saying that can we also start looking at private clouds where we can actually start deploying these services and what options we have. Overall, I think over the last 6 or 7 years, working with Aerospike has been a great experience of working with a highly stable kind of a persistent store that provides a very stable I/O characteristics, latency characteristics, as well as being able to scale to the levels we're looking at. And I'm looking forward to kind of doing more of these things as the time goes on. So thank you very much. I'm going to stop here. If you guys have any questions for me, please feel to reach out to me, Adobe, Nawate@adobe.com. Thank you.